Okay, so we will be discussing finding the solutions of x in a rational inequality. So we already learned how to find the value of x in a rational equation. So normally we will be having a one value or two values, no? So there are only few values of x. However, when we are dealing with rational inequalities, so we tend to have values of x wherein the values of x are represented as an interval. So this is not limited to only one value or two values, no? So there will be more than two values of x. So in finding the values of x, so there are a series of steps. Okay, so the first one is to equate the transform the inequality, rational inequality, wherein the left hand side contains all the values and the right hand side will be having only a value of 0. So at this part, we just need to transfer this 1 from the right hand side to the left. So we will be having 2x plus 10 over x plus 3 greater than or equal to, minus 1 greater than or equal to 0. Okay? So next is to simplify the left hand side. So this will be 2x plus 10 over x plus 3 minus x plus 3 over x plus 3 greater than or equal to 0. So further simplify this one. So this will be 2x minus x will be x. 10 minus 3 will be 7. X plus 3 greater than or equal to 0. Okay? So that is the first step and the second step. So again, transform the right hand side to 0, and the second step will simplifying the left hand side. So the third step is to separate the denominator and the numerator. So equate both of them to 0. So this will be x plus 7 is equal to 0. So this will be the numerator. And the denominator will be x plus 3 is equal to 0. So the value of x will be negative 7. The value of x on the denominator will be negative 3. Okay, so I would like to draw a number line about this. Okay. So I'll be having, I think this will be better at negative 8. Negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, 3, negative 2, negative 1, 0, 1, 2. Okay, so this will be our number line. So using these two values, negative 7 and negative 3, so let us try to create a wall. So at negative 7, so I will be creating a wall at negative 7. And at negative 3. Okay, so maybe I would like to name this partition A, B, and C. Okay, now we have the simplified inequality expression, which is x plus 7 over x plus 3 greater than or equal to 0. Now we will try to prove each regions A, B, and C. We prove the arguments in each region. So we just need to pick any numbers lying on that region. Okay? So for example, for region A, let's prove that if region A is true. Okay, so I need to get a number lying on region A. So this will be, so I think I'll be using negative 10. Let's say x is equal to negative 10. Okay, so this will be negative 10 plus 7 over negative 10 plus 3 greater than or equal to 0. So negative 10 plus 7 is negative 3. Negative 10 plus 3 is negative 7 greater than or equal to 0. Negative 3 over negative 7 is also 3 over 7 greater than or equal to 0. So is this argument true or false? So apparently this argument is true. So meaning to say, values lying on region A will be a solution of x on this expression. Okay? So this include negative 8, negative 9, negative 10, negative 11, negative 100, negative 1000. Okay? So let's prove region B. So let's just get a number lying on region B. So I think I will be using negative 6. Okay? So this will be negative 6 plus 7 over negative 6 plus 3 greater than or equal to 0. So negative 6 plus 7 is 1. Negative 6 plus 3 is negative 3. So this will be negative 1/3 greater than or equal to 0. So negative 1/3 is not greater than 0, no? Or even equal to 0. So this will be false, no? So it means that the values lying on region B will never be a solution of x on this expression. Okay? On this expression. Now let's try to prove letter C. So let us pick a number lying on region C. So I'll be using 0. Okay? So x is equal to 0. So 0 plus 7 over 0 plus 3 greater than or equal to 0. So this will be 7 over 3 greater than or equal to 0. And 7 over 3 is greater than 0. So this will be true. So all values lying on region C will be a solution of x in our expression. So region A, all values on region A will be solution of x. Region C will also be a solution of on our expression. Okay? So we only have, and B will not be included to the interval, okay, of values of x. Okay? So one problem here is if negative 7. So we place a boundary at negative 7 and also a boundary in negative 3. So is negative 7 or negative 3 will be included to the interval values of x. So let's test it out. So if x is equal to negative 7, so this will be negative 7 plus 7 over negative 7 plus 3 greater than or equal to 0. So negative 7 plus 7 is 0. Negative 7 plus 3 is 4. So still our answer will be 0. So greater than or equal to 0. And 0 is equal, no? So 0 is equal to 0. So meaning to say this statement is true. Hence, our negative 7 will be included to the set of values. So I'll be placing here a solid circle indicating that negative 7 is included. Okay? And next is x is equal to negative 3. If x is equal to negative 3, this will be negative 3 plus 7 over negative 3 plus 3 greater than or equal to 0. This will be 4 over negative 3 plus 3 is 0. And apparently, you cannot divide a number by 0, which will cause you to arrive to an undefined answer. So there will be an undefinable answer. So so negative 3 should not be included to the set of values. So I will not include negative 3, so it will be best to place an open circle here. And learning the interval notation, so we could name the value of x here. So this will be from left to right, so this will be negative infinity. So negative infinity, I'll be using parentheses beside it, comma, the next significant value after negative infinity is negative 7. Negative 7, and it is represented by a solid circle, so negative 7 is included, so I'll be using a bracket, union, the after negative 7 from left to right will be negative 3. So negative 3, I'll be using parentheses because this is an open circle, comma, positive infinity. So I'll be using positive infinity, comma. So this is our value of x in this inequality. So